Are you eager to delve into the captivating tapestry of human history, uncovering the remarkable journey that has led us to the present day? Look no further. Embark on an enthralling expedition with us as we unravel the epic saga of humanity, spanning across the ages. But that's not all. By simply liking and subscribing, you'll gain exclusive access to a treasure trove of knowledge as we meticulously document and narrate our collective odyssey. From the very dawn of civilization to the awe-inspiring advancements of today, prepare to be captivated by the riveting tales of triumph, discovery, and innovation that have shaped our world. Very well, let us begin this captivating journey without delay. Euclid was not the first to study geometry, nor the last. But he was the one who made it a science. He organized and systematized the knowledge that had been accumulated by previous generations of mathematicians, and added his own discoveries and innovations. He wrote his elements in a clear and concise language, using symbols and diagrams to illustrate his arguments. He presented his geometry as a logical structure, built on a few basic principles that he assumed to be self-evident. He then used these principles to prove hundreds of propositions and theorems, covering various topics such as plane geometry, number theory, proportions, irrational numbers, and solid geometry. Euclid's Elements was not only a masterpiece of mathematics, but also a masterpiece of education. He designed his book as a textbook for teaching geometry to his students at the Library of Alexandria, the most famous center of learning in the ancient world. He arranged his book in a pedagogical order, starting from the simplest concepts and gradually progressing to the more complex ones. He divided his book into 13 books, each containing a number of definitions, axioms, postulates, propositions, and corollaries. He also included exercises and problems for his students to practice and test their understanding. Euclid's Elements was not only a textbook, but also a challenge. He invited his readers to question and verify his claims, to find alternative proofs or counterexamples, to extend or generalize his results, to discover new ones. He also left some gaps and difficulties in his work, either intentionally or unintentionally, that stimulated further research and debate among mathematicians for centuries to come. One of the most famous examples of this was his fifth postulate, also known as the parallel postulate, which stated that if a straight line crossing two straight lines makes the interior angles on the same side less than two right angles, the two straight lines will meet on that side if extended far enough. This postulate seemed less obvious and more arbitrary than the others, and many mathematicians tried to prove it from the other axioms or postulates, or to replace it with a simpler or more natural one. However, none of them succeeded in doing so without creating contradictions or inconsistencies in Euclid's geometry. It was only much later, in the 19th century, that mathematicians realized that there were other possible geometries that did not satisfy Euclid's fifth postulate, such as hyperbolic geometry and elliptic geometry. These geometries opened up new horizons for mathematics and physics, and challenged the notion of absolute truth and certainty in geometry. Euclid's Elements was a remarkable achievement in the history of mathematics. It was the first and most comprehensive treatise on geometry, covering various topics such as plane geometry, number theory, proportions, irrational numbers, and solid geometry. It was also the first and most successful example of an axiomatic system, using a few basic principles to derive hundreds of propositions and theorems by logical reasoning. It was a clear and rigorous work that set the standard for mathematical proofs for centuries to come. Euclid's Elements was also a lasting legacy for humanity. It was the most influential and widely read mathematical work of all time, influencing many other fields of science, art, philosophy, and education. It was a source of knowledge and wisdom for generations of mathematicians, scientists, philosophers, artists, and teachers. It was a treasure of culture and civilization that we can still enjoy today. If you enjoyed this video, don't forget to hit that subscribe button and give it a thumbs up. I'd love to hear your thoughts in the comments below. Thank you so much for watching.